Welcome to qnawire.
All right, in this question we are asked to complete and balance the half reactions and then indicate whether the half reaction is the oxidation half reaction or the reduction half reaction. So in this first half reaction we have one tin on the left and one tin on the right, and there's no other elements to balance. So all we are balancing for is charge. There's a +2 on the left, a +4 on the right, so we need to add 2 electrons to the right in order to balance out the charge. Because we have balanced electrons to the right, they are a product, therefore the reaction is losing electrons, therefore this is an oxidation reaction. B, we have one Ti on the left and one Ti on the right. Next we need to balance for oxygen by adding waters. So we have 2 oxygen on the left, so I'll add 2 waters to the right. But now we have added 4 hydrogen to the left, so we need to add 4 H plus to the left. And now our overall charge on the left-hand side is a +4, and our overall charge on the right-hand side is a +2. Therefore, we also need to add 2 electrons to the left. And you would want to write this all out nicely in a straight line. And so since we are adding electrons to the left-hand side, we are gaining electrons. This is a reduction reaction. And the next one, we have 1 chlorine on the left and 1 on the right. We have 3 oxygen on the left, so we need to add 3 waters to the right. That gives us 6 hydrogens, so we're going to add 6 H pluses over to the left-hand side. So our overall charge over here is +6. -1 is this +5 over here, and this is a -1. So we need to add 6 electrons to the left-hand side in order to balance out the charge. And since we are adding electrons to the left, they are a reactant. This is, again, a reduction reaction. On the next one, we have 2 nitrogens on the left and only 1 on the right, so we're going to start by putting a 2 coefficient in front of NH4+. That gives us 8 hydrogen on the right, so we need to add 8 H pluses to the left. This gives us an overall charge of +8 on this side and +2 on this side. So we're going to need to add 6 electrons to the left to make the side the same as +2. And again, since we are adding electrons to the left, this is another reduction reaction. Now we switch to basic solutions. So for this one, we have 2 oxygen on the left. So I'm going to start by putting 2 here. That gives me 2 hydrogens on the left, so I need to add 2 H pluses over here. Then I'm going to balance for charge. I have a -2 on the left and +2 on the right. So I'm going to add 4 electrons to the right to make the overall charge on this side -2. But since this is basic, I now need to go and neutralize my acid by adding however many H pluses I have. I add that many OH minuses to both sides. So I'm going to add 2 OH minuses to this side, plus 2 OH minuses to this side. And then adding it all together, I'll rewrite this. This is 4 OH minus over here, yields O2, plus, now these combine to make water, so that makes 2 waters, and then my 4 electrons. All right, in F, I have 1 sulfur on the left and 1 sulfur on the right. I have 3 oxygen on the left, but 4 on the right, so I'm going to add a water molecule over here. That now adds 2 hydrogen to the left, so I need to add 2 H pluses to the right. My overall charge here is -2. My overall charge here is 0. Therefore, I'm going to need to add 2 electrons to the right. And now I need to balance out my acid, so I'm going to add 2 OH minuses to both sides. And then I'm going to rewrite everything. So over here I have SO3 2 minus. Now here, this is going to make 2 waters. So these are going to combine to make 2 waters, and then I can actually simplify my waters. So this one can subtract over and change this into a 1. So the only other thing I have over here is my 2 OH minuses. And then on the left I have SO4, 2 minus, plus that 1 water that's left, plus my 2 electrons. And then since the electrons are on the right, I'm losing them. This is oxidation. And I forgot to mention over here, but also on this one, because the electrons are on the right, I'm losing them. This one is also oxidation. Finally here, I have 2 nitrogen on the left, so I need a 2 here. That gives me 6 hydrogen on the right, so I need to add 6H plus over here. So my overall charge is a positive 6 on the left and a 0 on the right. So I need to add 6 electrons to the left, or to the left. Then I need to neutralize my acid. So I have 6H plus here. I need to add 6 OH minuses to both sides so I don't unbalance anything. All right, and then these are going to combine to make 6 waters. So on the left, I have N2 plus those 6 waters plus the 6 electrons yields 2 NH3 plus 6 OH minus. And since the electrons are on the left, they are a reactant. This is another reduction reaction.